Hello and welcome to our lesson on solving rational equations. So we're switching gears a little bit with this topic. So far everything in this module has been dealing with simplifying rational expressions. Now we looked at the operations, adding, subtracting, multiplying, dividing, but those were all just expressions. So now it's going to be solving, instead of simplifying rational expressions, solving rational equations. So we're still going to be looking at a fraction of polynomials, but now we're going to have a fraction of polynomials before and or after an equal sign. So we're dealing with rational equations, fractions of polynomials before and or after an equal sign, which means we're looking for values of x that are going to make that equation true. Okay, now we have to be particularly careful with rational equations because they have restrictions. Anytime there's a restriction in our equation, there's a possibility of ending up with what we call an extraneous solution. Now, what do I mean by restrictions? Well, fractions are restricted. Just a fraction, normal or fraction, is not defined when the denominator of that fraction is equal to 0. So if we're talking about a rational expression or equation, any value of x that makes the denominator equal 0 has to be excluded as a possibility for x. Right? So think about this the same way we thought about domain. Okay, for example, with this expression here, I know it's only one side of the equal sign, but in that particular expression, there's a value of x that would be no good here. If I put a negative, sorry, I don't know what happened there. If I put a negative 1 in there for x, negative 1, positive 1 cancels and makes a 0 in the bottom of that fraction, and 0 in the denominator of a fraction is undefined. So negative 1 would have to be restricted from that particular expression, or as an equation, if we looked at the whole thing, it would have to be restricted from that whole equation. So every once in a while, it's a small percentage of the time, but every once in a while, you will solve an equation, and the solution ends up being one of those restrictions, which means when you plug it in, it makes something that is undefined. If that happens, then that equation is not going to have a solution, okay? Or that particular solution is called extraneous. So it's a solution that when we plug it back in, makes something that is undefined. It doesn't actually count as a solution. Okay, so values of x that make the denominator, equal 0 must be restricted. They have to be restricted as possible solutions in the same way they would have been restricted from the domain. Okay, now if a restricted value occurs as a solution, we are going to call it an extraneous solution. And even though it's called an extraneous solution, it is not actually considered a solution because it would make our equation undefined. Okay? And I'll show you what happens. Sometimes that means you won't have any solutions at all. Sometimes you end up with multiple solutions. One's extraneous, but then one is still going to be valid, and we'll see these things occur. Okay? So here's two examples of what rational equations would look like. Let's just talk about restrictions for a second. So in this first fraction, we would say that x could not equal a negative 1. So we would say it has a restricted value of negative 1. And then what about the second denominator here? What would we plug in for x that would make that equal 0? It would have to be a positive 5 to cancel that negative 5. So we would say that x could not equal a positive 5. So these are restrictions. Or we could call them also restricted values. Okay, so x could not equal negative 1 or positive 5 for that first equation. How about the next one? What would I put in this denominator to make a 0? Well, 3 times what would be 0 would have to be 0, right? So we would say x could not be 0 for this equation. And then here, we would say x could not be a positive 4. So negative 1 and 5 would be restricted as possible solutions from that first equation. They would also be restricted from the domain of each of those if they were functions. And then 0 and 4 would be restricted values for the second equation. Okay, so if we were to solve and one of those numbers were to come up as a solution, we couldn't actually count it as a solution. Okay, now to add to this, we want to be looking for those restricted values first, but there are two approaches we could take to solve, and they're sort of based on the complexity of the equation that we're dealing with. Do you notice the difference between the two examples that we just looked at? So the first equation is what we call a proportion. The proportion has one fraction equal to one fraction. So we have one fraction here equal to one fraction here. That's called a proportion. Now if we have fractions on either side and anything extra, like a plus, minus, whatever, anything additional, if it's more than one solid fraction on either side of the equal sign, then it's not a proportion. And we're going to take a different approach for solving. So proportions, this is sort of like the complex fractions. Remember we said if we had one fraction over one fraction, it was pretty straightforward. We would just keep, change, flip. If it wasn't, then we would try to make it that way so we could keep, change, flip. Okay, so similar concept here where we have these like two types of equations we're going to deal with. So the proportion is the easier of the two. Let's start there. A proportion is an equation with exactly one fraction on either side of the equal sign. And proportions have a nice feature. I'm not sure if you know this. You probably do, but maybe it's been a little while since you've seen it. So these are all examples of proportions, right? 2/3 we know is equal to 4/6. 1/2 we know is equal to 5/10. 2/9 is equal to 16/72, and maybe that one's not as obvious, but what's true about a proportion is not just that you have one fraction equal to one fraction, but if we were to find the cross products, so for example, 4 times 3, we get 12, 2 times 6, we get 12. What happens is those cross products will have to be equal, and it happens here again. 5 times 2 is 10, and 1 times 10 is 10. The cross products are equal. 9 times 16 is 144, and 2 times 72 is 144. Those cross products are equal. That's always true in a proportion. So we can use cross products to solve a proportion. So cross products, the cross products of a proportion must be equal. So to solve a proportion, we still want to start by listing out our restrictions, just to be safe, list out our restrictions, but what we want to do is cross multiply. If we cross multiply, we won't have fractions anymore. Cross multiply, we're left with something that is linear like this, okay? It's going to be, fractions are gone, right? We cross multiply and those cross products have to be equal, so we'll just solve the remaining equation. For example, here. This is a proportion. These cross products have to be equal. So I'm going to cross multiply 4 times 6x, and I'm going to cross multiply here 9 times x minus 1, and make sure that if it's more than one term that you distribute, okay? These cross products have to be equal. So 24x on this side has to equal 9x minus 9 on the other side. And if you had written that in reverse, so if you had put the 24x over here and put the 9x minus 9 over here, it doesn't matter, okay? I just try to follow my arrows. But from here, this is a linear equation. We just want to get these x's together, get the like terms together so that we can get x by itself. So I'm going to subtract 9x from both sides. It's going to cancel that out. And that would leave me 15x here equal to, I still have a negative 9 on this side. Now I can divide both sides by 15. Cancels that out. And that makes x equal negative 9. Doesn't divide by 15, but that is a fraction that reduces. So we're going to reduce and say our answer is negative 3/5. And that is our solution. Oops, I forgot. Look it, I forgot the first step. There is a restriction in this one. Luckily I remembered in the end. This denominator 9, I can't make that equal 0. There's no x in it, so I don't have to worry about a restriction there. But here we have a restricted value. We have a restricted value 0. X cannot equal 0 because 6 times 0 would put a 0 in the bottom of that fraction. So there's a restricted value of 0. This solution is not a restricted value, so it's a valid solution. So negative 3/5 we're good with. Okay. Number 2, again, there's no way for me to make this denominator equal 0. There's no x in it, so I don't have to worry there. But on this one, x cannot equal positive 3. So we have a restricted value. We're going to say x can't be positive 3 because 3 minus 3 would put a 0 in the bottom of that second fraction. All right, so there's our restriction. We know what x can't be. Let's cross multiply to figure out what x can be. So if we cross multiply here, 3 is going to have to distribute to x plus 3. And then if I cross multiply here, 5 is going to have to distribute to x minus 3. And again, those cross products have to be equal. So we have 3x plus 9 on one side equal to 5x minus 15 on the other side. And now I want to get my like terms together. So it doesn't matter which way you go here. I'm going to start by subtracting 5x from both sides. That cancels that out. So I have a negative 2x plus 9 equal to a negative 15. Now I want to get x alone, so I'm going to subtract 9 from both sides. So now I have negative 2x equal to negative 24. And then lastly, I can divide both sides by negative 2. That cancels that. And so x is going to equal positive 12. And that is not a restricted value, so positive 12 is going to be a valid solution. Okay, and I wouldn't do this every time, but if you want to verify your work, remember how to check a solution to an equation, you plug it in, right? So we have 5/3 on one side, and apparently on the other side, 12 plus 3 over 12 minus 3, if I plug that x in, I should get 5/3 again. Oops, let me hit my little fraction button, and there it is, 5/3. Okay, so you can always check your work by plugging that answer back in. Alright, so here's one if you want to give it a shot. Feel free to pause the video. Let's see, restricted values. Here we have two restricted values. X cannot equal a positive 4 or a negative 1. Positive 4 would cancel the negative 4 and make a 0. Negative 1 would cancel the positive 1 and make a 0. So we can't be 4, we can't be negative 1. Alright, so we know what we can't be. Let's cross multiply and find what we can be. So 5 is going to multiply to x minus 4. And 3 is going to multiply to x plus 1. And those cross products must be equal. So 5x minus 20 has to equal 3x plus 3. Now I want to get my like terms together, so I'm going to subtract 3x from both sides. It's going to cancel that one. So I have 2x minus 20 equal to 3. And now I want to get x alone. So I'm going to add 20 to both sides. And now I have 2x equal to 23. And then my last step is to divide both sides by 2. That cancels that. And this one doesn't divide or reduce. So my answer is going to be 23 halves. And that was not restricted. So 23 halves is going to be a valid solution. Okay? Not so bad. If we have a proportion, just cross multiply. Just make sure that you don't have a solution that is a restricted value. Okay? And hopefully that's something that you've seen before. Now, the tougher ones are these guys. What happens when the rational equation is not a proportion? If it's not a proportion, we can no longer just cross multiply to solve. So what do? Let me try to show you something to make this make sense. There's lots of different ways to do this, but I'm going to show you the way that I have found to be most successful. Let me give you a simple equation like, what if I had 1 over 5 plus x over 5 equal to 4 over 5? Okay? If I had 1/5 plus x fifths equal to 4/5, I'm hoping that looking at this equation, you can see the answer. 1/5 plus how many fifths is going to give you 4/5? Hopefully you can see that x has to be 3, right? 1/5 plus 3/5 is the only way to get 4/5 when you add those two fractions, okay? So x has to equal 3. Now what if I change my denominators? Let's say this was 6 and 6 and 6 here instead. Does that change my answer? 1/6 plus how many 6 is going to make 4/6? Well, it still has to be 3, right? 1 plus 3 is still going to give me the 4 in the top. Alright, well what if I change them to 7s? 1/7 plus 3/7 is the only way to get 4/7, right? Or if I change them to 8s, 1/8 plus 3/8 is the only way to get to 4/8. So, what is the point I am trying to make here? Okay, the point I'm trying to make here is that if all of the denominators are the same, then they don't really affect the problem, right? If all of those denominators are the same, the only thing I have to look at to get my solution is the top. The top of this fraction, which was the 1, the top of this fraction, which was the positive x, and the top of this fraction was the 4, that's the only thing I need to see my solution. So that's going to be the goal when we don't have a proportion. The goal is going to be to get all of those denominators to be the same, because once the bottoms are the same, then all we need to focus on is the tops to get our solution. If the bottoms are equal, the tops have to be equal too. So here, we still again want to look for those restricted values, and sometimes I get forgetful, but we'll get those. And then we want to get common denominators. Okay, if the denominators are equal, then the numerators must be equal too. So in essence, once the denominators are equal, we can ignore them. We're not canceling them out or anything. We can just ignore them. We no longer need them to solve. So we can solve using just the numerators. Okay, so let's try it out here. Let me go ahead and make this a fraction over 1. So our denominators are 3x, 1, and x. What would our common denominator be here? Least common denominator for those three denominators would have to have a 3 and an x. So if I can get all of those denominators to be 3x, then I'd be in good shape. I wouldn't have to worry about those denominators anymore. So the first fraction's good. The second one I'm going to have to multiply by 3x over 3x. And then the third one I'm going to have to multiply by 3 over 3. So now all of those denominators are the same. If all of my denominators are equal, I can ignore them. All I need to look at now are the tops of the fractions to solve. So from the first numerator, I'm bringing down the 5. I'm going to carry down my equal. So 5 comes down, equal comes down. And then 1 times 3x here gives me a 3x to bring down. Don't lose your minus, that comes down. And then 3 times 3 makes 9. That's all we have to solve here. So we're going to get x by itself. If we add 9 to both sides, that cancels. Now we have 14 equal to 3x. Now I can divide both sides by 3. Cancel that out. And so we have our solution. 14/3 doesn't reduce or divide, so that's going to be our answer. And since I forgot earlier, what's restricted? What can x not be? X cannot equal, let's see, 0 would be no good there, and 0 would be no good there. So x can't be 0. Since 14/3 is not restricted, that's going to be a valid solution for us. Okay? So 14/3. That wasn't so bad. All right, let's try another one like that. And let's not forget this time, and I say let's, it's me. Let me not forget this time to find our restrictions up front. So only one restriction. There's only one fraction here. There's only one restriction. X can't be 0. So x cannot equal 0. And then let's get our common denominator. What's our least common denominator going to be here? Well, there's only one denominator other than 1. It's got an x, so that's got to be the common denominator. So now if I make all of these denominators have an x, and x here, then we're good. All of those denominators now have 1x. Once all of the denominators are equal, we can ignore them. They are no longer going to affect the problem. So let's focus on what we have left in our numerators. So this numerator, x times x, is going to give me an x squared. Bring down the plus. Second numerator has a 12 in it. Bring down the equal. And then the third one is going to give me a negative 7x. So now here's the equation I'm left to solve. Now this equation looks a little different from the last 4 that were linear. This one is quadratic. We solve quadratics by factoring. So we want to add the 7x over to this side to get this thing in order and equal to 0. And now I have x squared plus 7x plus 12 equal to 0. And now I can factor. Let's see, different color. How about gray? If I factor here, let's see, 12, 1 times 12 is 12. Factors of 12 that make 7 would be 3 and 4. And dividing by 1's not going to change those. So this is going to factor into an x plus 3 and an x plus 4, which means our solutions are going to be a negative 3 and a negative 4. And neither one of those is restricted, which means they are both valid solutions. So this equation has 2 valid solutions. Neither one of those was restricted. Okay? Alright, let's keep moving along here. One for you to try. If you're feeling confident with this, feel free to pause the video. Otherwise, let's continue. So let's make that a fraction. What's restricted in this equation? No restriction here, no restriction here, because those two don't have any variables. All we have is a positive 2 as a restriction in the third fraction. So up front, I know x cannot equal 2. And to solve this, I'm going to get all these denominators to be the same. So what is my least common denominator going to have to include? Well, it's going to have to include a 7, and it's going to have to include this x minus 2. So 7x minus 2. 7 and x minus 2. That means this first fraction has to be multiplied by x minus 2. This one in the middle here is going to have to be multiplied by the whole thing, the 7 and the x and the minus 2. And then the third fraction here, we're going to have to multiply by 7. So I have 7 times x minus 2, 7 times x minus 2, 7 times x minus 2. Now that all of those denominators are equal, we can ignore them. So now we can focus on our numerators. So in this numerator, 2 times x is 2x, and 2 times negative 2 is a negative 4. Here, got to be careful. We want to multiply to make 28 first, and then 28 times x is 28x, and 28 times negative 2 is a negative 56. And then lastly, don't lose the minus here. 3 times 7 makes 21. So here we are. Now we have a linear equation, but we got to clean this up a tad. We have on this side, I'm going to leave the 2x minus 4 alone, but on the other side, I'm going to combine my like terms. So I have 28x, and these go together. Negative 56 and negative 21 gives me negative 77 altogether. Now I'm going to get my x's on the same side. So let me subtract these 28 over. And maybe you choose to subtract the 2. It doesn't really matter. I just like to bring the letters to the left. So negative 26x. Still have a minus 4, still have an equal negative 77. Now I'm going to get this x by itself. So let me add 4 to both sides. That leaves me negative 26x equal to negative 73. And then I just have to divide. Divide both sides by negative 26. That cancels. And x equals negative negative makes our answer positive. 73 over 26 is not going to reduce. So positive 73 over 26 is our answer. And 73 over 26 was not restricted. The only restriction was 2, which means this is a valid solution for us. Okay? It was a little tough for a U-try, I think, but hopefully you're okay with that. All right, let's look at these next few. These next few, actually, in my opinion, looking at them, they look tougher than the others, but same process, okay? We don't have a proportion, so let's determine what's restricted and what common denominator we can use to solve. So before we can get a common denominator or see the restrictions, if we have any denominators that are factorable, remember that's got to be factored first. So let's see over here, factors of negative 6 that make negative 1 would be negative 3 and 2, and dividing by 1 is not going to change those. So this denominator is going to factor conveniently, and you'll see why in a second. It's conveniently factor into an x minus 3 and an x plus 2. So that's the denominator we're looking at here. Okay? So what is restricted? What can x not equal? Well, x cannot equal a positive 3, and it cannot equal a negative 2 because they'd mess up the fractions. Put zeros in the bottom, no good. Okay? Now what about the common denominator? Common denominator, one of each binomial. X minus 2, plus 2, x minus 3. So that third fraction is good. It's got the common denominator. But the first one needs to be multiplied by x plus 2 over x plus 2. And this one's going to need to be multiplied by x minus 3. Okay, but now we're in good shape because all of the denominators look the same. Now we can ignore those denominators and focus on our numerators. So this numerator gives us 3x plus 6, 3x plus 6, plus over here 5x minus 15. plus 5x minus 15 equal to, on this side, just the 5x. So that is, combine like terms, 8x's, and combine these, 6 and negative 15 is going to give me negative 9. So 8x minus 9 equal to, I still have 5x on the other side. Now I'm going to get those together. Going this way this time because I don't have a constant on both sides. So I'm left with negative 9 equal to negative 3x. And then my last step would be to divide. So dividing both sides by negative 3, I end with x equals 3. But what did we say in the beginning of this problem about x equals 3? Well, if I put x equals 3 in here or in here, it's going to make a 0. That is no good. We said x equals 3 had to be restricted as a solution because it would make our denominator equal 0. So this is what we call an extraneous solution. This is an extraneous solution. So I said it's not going to happen often, but every once in a while you're going to solve and you're going to get an answer that makes your denominator equal 0. That's restricted. So that can't actually be an answer. We said 3 had to be restricted. So if the only solution that occurs to this equation is one that doesn't actually work, what does that tell us about this equation? Well, it tells us this equation has no valid solution. Okay, so there is no valid solution for this equation. All right. Let's keep moving. So if that question occurred, let's say on a practice or on a test, the answer would be no solution. You wouldn't say x equals 3 because it's extraneous. It's not counted as a solution. Unless I said, what's the extraneous solution? Then you would say x equals 3 is the extraneous solution. But if I just said solve, then you would say there is no solution. Okay? All right, let's try another one. Here's another where we've got a factor. What are the factors in negative 8 that make positive 2? That's going to be positive 4 and negative 2. Again, that's convenient since those are the same two binomials we have in our other fractions. So over here, what can x not equal? X cannot equal positive 2. X cannot equal positive 4. And our common denominator is going to have to be one of each of those binomials. X minus 2 and x plus 4. So the first fraction needs to be multiplied by the x plus 4. Second one needs the x minus 2. And the last one is good. Okay, now all of those denominators match. They've all got both binomials. So now we can solve using just our numerators. So 2x plus 8 here. Plus, we've got a 8x minus 16 from the second denominator, and a negative 6x from the last one. Okay, combine some like terms. 2 and 8 leaves me 10 x's, and 8 minus 16 is going to leave me with negative 8 on this side, and I still have negative 6x here. Let me get those x's together. So if I subtract these 10 over, I'm left with negative 8 equal to negative 16x. And one last step. To get x by itself, I'm going to divide over the negative 16, so that cancels. And that leaves me x by itself equal to negative negative makes a positive, and 8 doesn't divide by 16, but that reduces to a half. And 1/2 was not a restricted value, so we're going to call 1/2 a valid solution. Okay? Valid solution. All right, last one. Again, if you want to give it a shot, feel free to pause and try it out. If not, let's see. This is a difference of squares. We want to factor this into x plus 5, x minus 5 before we do anything else. And now we can see that x cannot equal 5 or negative 5. And again, we have a common denominator that includes two binomials, an x plus 5 and an x minus 5. So we're going to multiply here by x minus 5, multiply here by x plus 5, and the third fraction is good. It's got the common denominator already. Now we got to be a little careful on this one with the minus. I'm going to go ahead and bring this up, distribute that to the 5. That way I make sure it gets distributed in the beginning. So now we can focus on these numerators. We've got a x squared here and a negative 5x, x squared minus 5x, and a negative 5x, and a negative 25. And then on the other side, just a 14. Okay, so this is another quadratic equation. We solve quadratic equations by factoring. So I'm going to get the 0 on this side, subtract 14 over, and I'm also going to combine these like terms. So I have x squared minus 10x altogether, and then minus 39, minus 39 equal to 0. So now we're left to factor. I need another color. We need factors of negative 39 that are going to make negative 10. So 3 goes in 13 times. If we make the 13 negative, we're good. So this is going to factor into x plus 3 and x minus 13, which gives us two solutions. We see here that x is going to be negative 3, and we see here that x is going to be positive 13. And both of those, or neither of those, is a restriction, so we're going to keep both of those as valid solutions. Okay? And there's that. Now, I just want to reinforce again that and I wouldn't do this every time, but if you want to check your work and make sure that your solutions are in fact valid, remember you could plug them in. So I'm going to go ahead and just verify my two solutions here. So I have, let's see, a negative 3 over negative 3 plus 5, and then I'm going to subtract 5 over negative 3 plus 5, and that's the one side, so I'm going to type in the other side separately. The other side I have 14 over negative 3 squared and minus 25, and I better get a 4 again, and I didn't. So what did I do here, people? Oops, typed this one in wrong. It helps if you're verifying your answers correctly. That's supposed to be a minus. Good grief. Okay, I'm like, I did not screw the solving up. Alright, so I typed the one side in, typed the other side in, and you can see both those sides came up with the same negative 0.875, which verifies that solution. Now I can do this again more easily the second time. Everywhere I've got this negative 3 now, I'm just going to put in a 13. So I'll get rid of this, and get rid of that, and get rid of that. And again, I can see I end up with the same decimal on both sides of my equation. So not only were those not restrictions, but I've just verified by plugging them back in that they are in fact the two correct valid solutions. Okay? So there it is. It's a lot to digest. Just make sure that you're not creating more work for yourself. Identify whether or not you have a proportion first, because if it's a proportion, then you can just cross multiply. If it's not, get a common denominator, and once your denominators are all equal, focus on solving with just those numerators. Okay, you've got some practice to give it a shot, but if you find yourself struggling, just reach out. I'm here for you. All right.